Okay, so now I'll be showing the first part, phase one, from the software implementation. So this is how the CNN convolution model looks like. It says convolution, value, encoding, the shape, value again, softmax 10. So now first we run this software. We run this. This is what the output is. This is the output. Convolution filter value. This is the input image. Please do remember the image is from the UNIVERSITI database. So first is figure 1. This is the feature. This is the input, the convolution filter, then the features, convolution plus the value. This is the input. This is the figure 5. Is feature convolution plus value plus input. So this part is very important because we need to get the data set. You see here first y1 data set. This is the data set where it has 400 data. This is the entire data for one feature. Then for the next part is value, is y2. See here data set which is on floating point. Then y3. This is the mean polling, the output after the mean polling. So what we do is using the right metric function, we convert the data to Excel. So that is the first part. The next part is showing on the Excel. So now after the MATLAB, using the right matrix function, we can transfer the data into the Excel. So if you can see here, first let me explain this. So this is the how the overall function will look like in the MATLAB. So first is the input that I get is from here. Mean from after the convolution filter. So this is the input. So each input will produce a 400 data. So using the matrix function, right matrix function, we can transfer the data into Excel. So this is what I mean by 400 data. This has around 400 data. So there's around 20 sets of features. So each has their own sets of value, which is 400 data. So next is the same goes for the value and mean, except for mean pooling, it only has around 100 data. So because mean pooling reduces the image size, it has around the 100 data. So each value is in floating point. What we need to do is we need to convert it into a fixed point and change it into a hexadecimal file. You please do remember that quarters using pointers, we can use floating point or unsigned value. So what we need to do is we need to convert it into hexadecimal file. So next is I create the settings in the Excel itself using the Excel function. Is this function? So now first is this is the 400 data for first feature. First we enter the data, then times with 32768, then round off it to nearest decimal, which is 0, and finally convert it into the hexadecimal. So please do understand this. I use 32-bit, but Excel produce 40-bit hexadecimal. So that's all for this part, which is in Excel. So the same goes for the output. So this is the output, which is the mean pooling. Enter the data times with 32768, then run off to nearest value, which is 0, then change to status. So please do remember this is important because using this data we can verify either the architecture in the quarters is uh, uh, producing the same value as the software. So that's all for this part. Next, we're presenting about the architecture in quarters. Okay. So now this is the quarters part for the hardware implementation. So first, explaining what I'm doing. So for my part, I'll be focusing on value and mean pooling. So my input will be this, which is convolution. There's around 20 features, and then it has each feature has 400 data. And same goes for the convolution value, and then the output. So this part I will not be placed as input because I'll be jumping on until the convolution, which is convolution value plus mean pooling, the model. That's how it works. So now let's go for the quarters. So feature one is the input one. If you see on this is the overall design for the auto implementation. So this is feature one. Feature one is input of the convolution, which each feature consists of 400 data. So the size of the ROM, please do remember that features from feature 1 to feature 20, I'll be storing it in ROM file. That's around 20 ROM file. As for the output, which is pool 1, pool 2, and pool 20, pool 1 to pool 20, the output will be stored in RAM, where the RAM consists of 1 to 20. So how the hardware implementation works is, first the 400 data will place on the ROM 1 and it will pass through the value and pooling 1. So this is the value and pooling 1 will be a model which I save as mean model in the quarters, and then the pool will be the RAM where the output will be stored in RAM. Now I'll be going for the quarters. So now there's around, as I said before, there's around 20 features where each feature consists of 100 data. So the output will also be 20. So each output consists of 100 data. So now you can see here, this is the ROM file and the RAM file, where it has until the 1 to 20 and the ROM file is 1 to. So now this is the coding for the first part, which is mean pool top, then the controller. So the controller is for the state of the for the mean pooling, and then this is the state for the address generator. Then for me, and this is the for the mean pooling equation. So now next part is we need to press this, and then we can see the waveform. So now I already set the waveform to the up out from 1 to 20. This is the output in RAM. So now from here we can see that the time taken to finish this execution is around 8050042 picosecond. So now after we got this waveform, uh, we need to verify either the data from the MATLAB and hardware implementation is the same or not. So how we're going to do is, as I mentioned in the second part, where we can see the output in Excel. This is the output in Excel. This is the value from the MATLAB, where I took it by using the arithmetic function. So now we need to compare this in the memory list. So first, this is the RAM file. If you press here, this is the RAM file. Change the properties to hexadecimal while the address radix is decimal. I use word per line is 10. So from here, we need to compare either the output is same or not. You see here, the output should be same. So 135, and this is 135, and until the value is until 100. So, so if it's same, then the architecture is working with the software. So now from here, we can say that we need to compare it with the software speed time and also hardware speed time. So the other data you can take from completion report. So for the hardware preparation, it takes around total logic element 4457. Then the total memory bits is 409. So that's all for me.